Hello, welcome to this learning module. Over the next series of videos, we're going to cover the topic of nomenclature, how we name molecules. There's a very systematic, very algorithmic way that we name molecules in organic chemistry, and it's called the IUPAC system for naming molecules after the International Union of Pure and Applied Chemistry, which governs the rules for naming molecules. Before the IUPAC names, every molecule had its own common name, and it was very hard to keep track of which molecule was which. If you had heard a name and you didn't know what structure it went with, it was kind of a memorization thing. With the IUPAC rules, there's a very systematic way. Anyone in the world can look at a name and know exactly what it means, even if you've never seen this particular molecule before. As we'll find, some common names kind of get grandfathered in, and we still call some chemicals by their common name, but for the most part we'll be dealing with the IUPAC names for molecules in this course. We're going to do this series of videos in a couple of parts. The first two videos are going to be more introductory videos, and the last couple of videos are all going to be examples. This can get a little rule heavy. There's a lot of rules and a lot of sub-rules and a lot of sub-sub-rules that we have to follow depending on the complexity of the molecule we're naming, and all those rules can get a bit heavy. So the first two videos I'm going to lay out the rules, which is fine. But in the last couple of videos, we're going to learn by doing. I'm going to show you some examples, and we're going to apply the rules as we go, which may sometimes be a better way of learning than just reading rules out loud. But let's start with the basics. The first thing we need to know about nomenclature is that all molecules are named as derivative of alkanes. All molecules are derived from some kind of alkane parent, alkane backbone. So we need to know what the alkanes are. We need to know how to name the alkanes before we can name anything else. There are all sorts of names for alkanes. We're only going to look at the top 12, the first 12 alkanes based on their chain length. And the chain length determines the name. We start with one carbon. One carbon is methane, 2 carbons is ethane, 3 propane, butane, pentane and hexane, heptane, octane, nonane, decane, undecane, and dodecane. Just saying those out loud so you can hear how we pronounce these. What's important is that first syllable of the word. That tells us how many carbons there are in that chain. The last couple kind of follow, the octane for 8 carbons, pentane for 5 carbons, but the first 4, again, this is kind of that common name nomenclature system, the first 4 don't, the first syllable doesn't really tell you how many carbons there are in that chain. We just have to kind of know these first 4. Methane, ethane, propane, and butane. These are the first 4 hydrocarbons. After that, we get kind of these numeric first syllables that kind of help us determine how many carbons there are in that chain. We have to know these before we can do anything else. You need to know these 12. And then you can go past 12, tridecane, tetradecane. There's even special words for 20 and or higher than that. We're not going to worry about those in this course. These are the ones that we need to know for this course. The next thing that we need to know is that there are 5 parts to every name when we name a molecule. These are the 5 parts. And they always go in this order. Stereochemistry always comes first, then the substituents, and then the parent, then the unsaturation, and finally the priority functional group. Those words may not mean much to you right now. Again, we'll learn by doing a little bit later, but I just want to kind of get us used to hearing these words, seeing the overall structure, overall pattern for naming, and then when we do some examples, it'll kind of fall into place. A couple of things I do want to point out. Stereochemistry is in parentheses because when we write the IUPAC name, we do in fact put the stereochemical information in parentheses. Not every molecule will have stereochemical and substituent information, but every molecule will have a parent, will have some kind of unsaturation information, and will have some information about a priority functional group. Again, whatever that means, we'll figure that out a little bit later. So you have to have these last 3 parts. You may or may not have these first 2 parts. And we'll kind of learn a little bit by doing here with these alkanes that we've just been talking about. All of these alkanes here actually demonstrate these last 3 parts of the name. The first syllable is the parent. The first syllable tells us how many carbons there are in that chain, and we refer to this in our language here as the parent. So meth, eth, prop, but, hept, non. Those tells us the number of carbons in that parent hydrocarbon. The next 2 letters, the AN, tell us about the unsaturation. The AN signifies to the reader that there are no double bonds in the molecule. Unsaturation is kind of another word for double bonds, not exactly, but it's close enough for right now. So the next 2 letters tell us about the number of pi bonds in the molecule. AN means that the molecule is composed entirely of single bonds. Other choices would be EN if we had any double bonds in the molecule, and YN if we had one or more triple bonds in the molecule. And we'll talk about how to update the name in the event that we do have double or triple bonds in a later video. And the last letter of the name tells us about the priority functional group. The E here actually is kind of a placeholder indicating a lack of a priority functional group. We'll talk about these in a later video, but these are just straight chain alkanes. There's nothing branching off, there's nothing unique, there's no other heteroatoms, no other groups, it's just straight chain alkane. So there's no priority functional group in these molecules, and so the last letter is a placeholder that tells us that there are no priority functional groups in these molecules. That's a start. Let's just start here. Let's just start with learning the first 12 hydrocarbons, the first 12 alkanes, and understanding that these talk about the parent, the unsaturation, and the priority functional group. Next video, we'll go through all the rules, and then we'll start doing some examples and start putting this all together.